Hello, evening. Sorry guys, call you this evening. I just want to inform you all our due date assignment format just around 2 weeks. So where we want to discuss about it.
This weekend you guys free or not? If you guys free, how about we meet the UTM? It's not too far from our campus.
For this weekend, I'm free, but it's too far. Plus, I have no transportation.
For this weekend, I actually really cannot because I handle event. But for times, maybe I can deal with later. But for the place, actually I have a vehicle, so any place I can go.
Okay lah, then we met at our midpoint lah. But where is exactly our midpoint lah?
Oh, no worries. Let me invite Adam to the group call. Maybe he can suggest the place that we can meet.
Come on. Who is this? Oh, AQIL. Hello AQIL. What's wrong? Why do you guys invite me to this call?
Hello Adam, you always play ML we just want to ask you.
So basically, we want to meet to discuss about our assignment. But then we don't know where exactly we want to meet. That's why we call you to decide where we're gonna meet.
Do you have any idea how to find our midpoint so we can meet together?
Oh, I see. So you guys want to find the midpoint of three of your location. Basically the closest to all of your location. I think I know a way. Yeah, here. I can explain to you. So it's like this. Hello everyone, and today we would like to do a video presentation talking about a method used in matrices, which is called elementary row operation, or known as ERO. First of all, what is elementary row operation? Elementary row operation are core linear algebra tools for systematically manipulating matrices while preserving essential mathematical properties. So the properties of the ERO method, elementary row operation, is there are three properties, or basically three ways you can use ERO, which is row switching, row multiplication, and row addition, which I will talk about later. Okay, so talking about the primary uses of arrows, or the types of arrows, meaning the ways you can use arrow, is basically there are three ways or three types of arrow. So firstly is interchanging two rows in a matrix. Let's say take for example a 3 by 3 matrix, means you have 3 rows and 3 columns. So for example, you can interchange the first and second row of a matrix by using a notation where R1 interchange with R2. You have to write a notation for it. And then secondly, you can multiply or divide a row by a scalar, means by dividing by or multiplying or dividing by a scalar means a constant, any number. For example, if the first row, all elements of the first row is multiplied by a number 3, that means you have to write a notation which is R1, row 1 is colon, or you can use colon or either an arrow where it is multiplied by 3. So R1 colon 3R1. So it shows that the row 1, all the elements in row 1 is multiplied by 3. And then thirdly, last but not least, is the third one, which is adding or subtracting to the corresponding elements of another row, which means you use another row to change the value of the elements by adding or subtracting another element from another row. For example, if the first row is added to the second row, we can write it either as R1 colon R1 plus R2 or R2 colon R2 plus R1. Whether it is between whether you want to change the values of elements of row 1 then you start with row 1. If you want to change the values of the elements of row 2, then you start with row 2, R2. So that's how you use arrow. Those are the 3 types of arrow. So why do we need to use arrow in matrices, in the matrix world? So arrow actually serves a purpose, like a very crucial purpose. And why do we need to use this method is because it can solve linear equations as well as it can find the matrices, the matrix inverses, which means the inverse matrix of a matrix, if the inverse, and we can prove whether the inverse matrix exists or not. So those are the 2 main purposes. And then there are also other purposes, such as finding the determinant of a matrix, and as well as determining the rank of a matrix, like determining the matrix of A or B. So there are 4 crucial purposes that arrow serves.
Thank you, Adam, for the brief introduction for our topic. So now we are going back to AQIL and his friends' problems. So they want to meet up for a meeting at the nearest point between all 3 of them. One of them stays at Pasir Gudang, that is 1.47 degree towards the north and 103.88 degree towards the west. The other stays at Iskandar Putri, that is 1.6 degree towards the north and 103.55 towards the west. While AQIL, he stays at Skudai, that is 1.52 degree towards the north and 103.65 degree towards the west. So where is the nearest place between all 3 of them? First of all, we have to change the positions of the 3 points into a coordinate system using these 3 ECEF equation, also known as Earth Center Earth Fixed equation, where theta is the latitude and the lambda is the longitude, and all of the positions of the points must be in radian. So we have to change all of the positions into a radian form first, and using the radian, we can substitute it into the equation. So from the calculation, we can finally get the coordinates of the 3 points in x, y, z form. So now we can make a matrix from the coordinates of the 3 points. To solve these problems, we are going to apply what we have learned from Adam before, which is using the elementary row operation. So by rearranging all of the coordinates that we get from the previous calculation, we will get this form of matrix. Now, to solve the problems and to get the nearest point between all of the 3 places, we have to add all of the coordinates and divide it by 3. But since we are solving it using the matrix form, we have to use the elementary row operations. First of all, we are going to change the row 2 by adding the row 1 to the numbers at the row 2. And we will end up with this form of matrix. After that, we are going to change the row 3 by adding the new numbers from row 2 with the numbers at the row 3, and we will eventually end up with this form of matrix. Last but not least, to get the average distance between the 3 points in x, y, z plane, we'll have to divide the numbers at the row 3 with 3, since there are 3 elements of x, y, z. Eventually, again, we will end up with this form of matrix. The numbers at row 3 will now be used for our further calculation. But the row 1 and row 2 numbers will be ignored. So now, using the 3 x, y, z coordinates from row 3, we can use this equation to calculate the value of longitude and latitude back again. So by substituting the values of x, y, z into the equation, we can finally get the final point of the nearest between the 3 places, which is 1.52 degree towards the north and 103.65 degree towards the west. even though the final calculation for the latitude is 76.35, we have to subtract it with 180 degree, because we have to consider the initial value of x, which is negative. So since the value of x is negative, then the positions of the places will end up at the second quadrant. Hence, the value of the degree will be changed. So since we finally have gotten our exact point that is the nearest between all of them, where is the place? Well, the place is actually at paradigm. So that is it for the calculation.
Okay, so basically you guys have to meet at paradigm 1, because which is the midpoint of your obligation. Okay, so do you guys understand?
Nice idea, bro. You really help us.
So the conclusion, we will meet in Paradigm Mall, yeah. That's good. I can shopping too.
Okay, then we meet at Paradigm Mall. Nice.
Okay, bye.